Proxima Centauri b, a gateway to life beyond Earth. In the vast, unfathomable expanse of space, one of the most astonishing discoveries of recent times is the exoplanet Proxima Centauri b. This planet orbits Proxima Centauri, the closest star to our solar system, located just over 4 light-years away. In astronomical terms, this is incredibly close, making Proxima Centauri b a prime candidate for exploration. But what really captivates scientists and astronomers about Proxima Centauri b is that it has some striking similarities to Earth. It lies within the habitable zone of its parent star, meaning it could potentially support life, just like our home planet. However, while Proxima Centauri b is certainly fascinating, the more exciting prospect is the discovery of planets that could have even more favorable conditions for life than Earth. This idea is becoming more and more popular among scientists and space enthusiasts alike, as we begin to realize that Earth, despite its seemingly perfect balance of temperature, water, and atmosphere, may not be the best planet for life after all. Imagine a world that has an abundance of water, fewer deserts, a more consistent and balanced climate, and vast, sprawling landmasses. Picture a planet where the conditions for life could be even better than what we experience on Earth, a true paradise. Such worlds may exist somewhere out there in the galaxy, just waiting for us to find them. The thought of discovering these kinds of superhabitable planets sparks incredible excitement about the future of space exploration, and the potential for humanity to spread beyond our home planet. The search for humanity's new home. As humanity pushes the boundaries of space exploration, scientists are working tirelessly to identify potential candidates for colonization. The dream of finding a terrestrial twin, a planet that closely resembles Earth, has been one of the central goals of astronomy. But now, with advancements in technology, the search has expanded. Rather than simply searching for another Earth-like planet, researchers are beginning to wonder if there might be planets out there that offer even better conditions for life. The search for these superhabitable worlds has gained significant momentum, and one of the most prominent advocates for humanity's future in space is renowned physicist Michio Kaku. As a co-founder of string theory, Kaku has become one of the most vocal proponents of humanity's potential to expand beyond Earth. Kaku envisions a future where humanity is no longer confined to a single planet. Instead, we could become a multi-planet species, or even take it further, to a point where we spread across multiple universes. Such a vision is crucial not just for the expansion of human civilization, but also for its survival. Earth faces significant existential threats, such as supervolcanoes, meteorite impacts, and glaciations, any one of which could potentially wipe out life on our planet. The idea of spreading humanity across multiple planets is not just an exciting fantasy, it's also a matter of survival. The first step, according to Kaku and many other experts, is to leave Earth and colonize other worlds. This need becomes even more pressing when you consider the fact that the Sun will eventually consume the Earth in about 5 billion years. In the distant future, humanity could find a new home on a planet similar to Earth, a place where we can continue to thrive. However, as our search for exoplanets continues, researchers are realizing that we may be looking for more than just Earth-like worlds. Instead, we may need to look for planets that offer even better conditions for life than Earth has to offer. The limits of Earth's habitability. In 2014, scientists Renee Heller and John Armstrong introduced a groundbreaking idea: to determine the habitability of a planet, we need to consider more than just its position in the habitable zone of its star. While Earth is often hailed as the most suitable planet for life due to its perfect combination of temperature, water, and atmosphere, it may not actually have the most ideal physical and chemical. The idea of superhabitable worlds challenges the long-held belief that Earth is the gold standard for habitability. In fact, some researchers believe that planets that are not Earth-like might offer better conditions for life. These superhabitable worlds could support even greater biodiversity, larger bodies of water, milder climates, and larger landmasses. Such planets might be more suited to sustaining life and creating diverse ecosystems, perhaps even more so than Earth can currently provide. What makes a planet superhabitable? Not all rocky planets in the habitable zone are suitable for life. Consider Europa, one of Jupiter's moons, which lies outside the traditional habitable zone. Despite this, it is believed that tidal heating beneath its icy surface could make Europa a candidate for harboring life. This raises the possibility that planets and moons outside the habitable zone could also harbor life, worlds that may not seem ideal based on traditional criteria but have the potential to support life nonetheless. Heller and Armstrong proposed the idea of developing an exoplanet profile to better understand which planets could be the most habitable for life. This profile would include a variety of factors such as star type, planetary mass, and planetary age, which could help researchers identify planets with the best potential for life. Some scientists are now considering orange dwarf stars, which are smaller, cooler, and much longer lived than our Sun. These stars have lifespans that stretch to an impressive 20 to 70 billion years, far longer than the Sun's expected 10 billion year lifespan. This extended lifespan could provide planets more time to develop life, potentially leading to an even greater diversity of life forms than we have on Earth. Size and mass matter. Another crucial factor in determining the habitability of a planet is its size and mass. A planet that is just 10% larger than Earth would have a much larger surface area, which would increase the amount of habitable land. It could also maintain a more stable atmosphere, helping to create ideal conditions for life. A planet that is 50% more massive than Earth would have a longer-lasting geothermal heat source due to its slower rate of radioactive decay. This would allow the planet's core to remain active longer, preserving the planet's magnetic field, and protecting the surface from harmful cosmic radiation. A larger planet would also experience stronger gravitational forces, which could help stabilize the planet's atmosphere and make it more conducive to life. Warmer and wetter worlds. Superhabitable planets may also have warmer temperatures than Earth. On Earth, tropical regions are home to a wide variety of species, and these environments tend to have high levels of biodiversity. On other planets, similar conditions could support even greater biological diversity. However, warmer temperatures could also lead to desertification, so these planets would likely require more rainfall to maintain balance and support thriving ecosystems. Water. The key ingredient water remains the most critical factor when assessing a planet's potential to support life. Oceans are essential for many forms of life on Earth, and planets with vast bodies of water would naturally be more likely to harbor life. However, planets with smaller, more divided land masses, similar to Earth, could also be suitable for supporting life. In Earth's oceans, biodiversity thrives in shallower regions, so planets with smaller bodies of water could also be more conducive to life. Exploring the vast expanse. Despite the challenges that remain in our ability to study distant exoplanets, the search for extremely habitable planets is an ongoing endeavor. Proxima Centauri b is just one of many targets in this quest. While it holds promise, Proxima Centauri b faces significant obstacles. The planet is tidally locked, meaning it has one side constantly facing its star while the other remains in perpetual darkness. This could lead to extreme temperature variations on the planet's surface. Additionally, the UV radiation from Proxima Centauri could disrupt the planet's atmosphere, making it difficult